What will the weather be like 3 weeks from today, at this exact spot? The question feels simple, but the answer is, fundamentally, unknowable. This isn't a failure of technology. It's a property of reality itself, discovered almost by accident in 1961. A meteorologist named Edward Lorenz was running a primitive weather simulation on a Royal McBee LGP-30 computer, a machine less powerful than a modern calculator. To re-examine a sequence, he re-entered a number from a previous printout. He typed .506, shortening the original value of .506127. This tiny, seemingly insignificant rounding error, a change of less than 0.02%, should have been negligible. Instead, the entire long-term forecast diverged into a completely different weather system. Lorenz had discovered sensitive dependence on initial conditions, the hallmark of chaos. The atmosphere is a chaotic system. We can never measure the exact temperature of every cubic millimeter of air, or the precise velocity of every water molecule. Small errors, smaller than any instrument can detect, double and redouble, cascading through the system until the forecast becomes pure noise. This creates a hard wall, not of technology, but of physics, somewhere around 7 to 10 days in the future. If a perfect 2-week forecast is physically impossible, why do we hold so much faith in tomorrow's prediction? Our brains are not built to appreciate chaos. They are built to find patterns. This is called confirmation bias. We don't remember the dozens of times the forecast called for scattered showers and the sky remained clear. We remember the one time we ignored a 30% chance of a thunderstorm and got utterly drenched at a family barbecue. That single memorable event reinforces the forecast's authority, while the numerous misses are quietly discarded from memory. This isn't a personal failing, it's an evolutionary advantage. For our ancestors, assuming the rustle in the grass was a predator, even when it was usually just the wind, was a life-saving strategy. A false positive, believing a pattern exists when it doesn't, is far less costly than a false negative. Our brain is a confirmation engine, constantly seeking evidence that validates our beliefs and models of the world, making us excellent survivors but poor statisticians. This biased thinking collides directly with the language of forecasting. You look at your phone and see a 40% chance of rain. What does that number actually mean? It's one of the most misunderstood metrics in daily life. It does not mean it will rain for 40% of the day, nor that 40% of your town will get wet. The official formula for probability of precipitation, or POP, is confidence multiplied by area. So a 40% chance could mean a meteorologist is 100% confident that 40% of the forecast area will see rain. Or it could mean they are only 50% confident that 80% of the area will see rain. The final number is the same, but the underlying meaning is different. Our brains, however, despise this kind of ambiguity. We engage in what psychologists call probability reduction, collapsing that 40% into a simple binary choice. I need an umbrella or I don't. We crave a yes or no answer from a system that can only speak in maybe. So we selectively remember forecasts and fundamentally misinterpret their language. Why do we keep coming back day after day? Because we aren't just looking for information. We are seeking a sense of control over an uncontrollable force. The simple act of checking the weather provides a psychological balm, an illusion of control. Knowing a storm is possible allows us to perform a ritual. We pack an umbrella, we cancel a hike, we secure outdoor furniture. These actions, in themselves, do nothing to alter the weather, but they do wonders to calm our anxiety about the unknown. It transforms us from passive victims of the elements into active, prepared participants. The forecast is a tool that helps us manage our internal emotional weather as much as the external atmospheric weather. We don't watch to know the future, we watch to feel prepared for it. Modern meteorologists understand our desire for certainty, but they also understand Lorenz's chaos. Their solution wasn't to build a single, more powerful computer model, but to build dozens of them. This is called ensemble forecasting. Supercomputers at weather centers around the globe don't just run one forecast. They run a simulation. Then they run it again after slightly tweaking the initial temperature by a fraction of a degree. They run it again after nudging the wind speed. They do this 50 or more times, creating a symphony of possible futures. When these simulations largely agree, showing a hurricane turning safely out to sea, forecaster confidence is high. But when the models look like a plate of spaghetti with wildly diverging paths, they know the future is deeply uncertain. The most advanced weather prediction doesn't give us one answer. It gives us a beautiful, complex map of all the answers that are possible. This complex relationship with prediction isn't just about the weather. We see the same patterns everywhere. We treat economic forecasts as gospel, hang on every percentage point of a political poll, and seek certainty in medical prognoses, all of which are complex systems fraught with their own chaotic variables. The daily weather report is a microcosm of a larger human story, our unending quest to impose order on a universe that is fundamentally probabilistic and unpredictable. So the next time you check the forecast, remember what you're really looking at. It's not just a prediction of rain or sun. It's a mirror. It reflects the limits of our knowledge, the biases of our minds, and our deepest, most human need to feel like we know what's coming next, even when we never truly can.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.